Day. It's an old translation, and it's hard to get a hold of certain things, and this is one of them. So what I want to do is do a first pass run through, just get the English out there into the interwebs. There are some formulas and things. I'm gonna show them and stuff, but I'm just gonna kind of gloss over them because I'm after the English, and I'm not gonna sit there looking at formulas. I'm just gonna read the English, and we're gonna go. So today is the preface. We're gonna take care of the preface, and then if all goes well, I'll do a chapter each night, and we'll get through this. So it's Introduction to Cybernetics by Victor M. Glushkov, Director, Cybernetics Institute, Academy of Sciences, Ukraine. Um, that was back in the day. So there we go. There's translation and translator. Oh, good. He's Department of Electrical Engineering. So that's going to be the translation. It's going to be from the aspect of electrical engineering. Okay, so preface. The purpose of this book is to familiarize the reader with a number of new fields which form the basis of cybernetics as it is currently conceived. In the most general sense, these fields can be subdivided into two large groups, one comprising the general theory. Okay, we got a glitch, so we're back. I lost your spot here. In the most general sense, these fields can be subdivided into two large groups, one comprising the general theory of information processing and the other the theory and structure of the various kinds of information processors. Each of these groups consists, however, of such an enormous body of accumulated knowledge that it would be impossible to treat it all, even synoptically, within a single book. For this reason, an author must be selective in his choice of material. In writing this book, we have used two major selection criteria. First, the material had to be available in a form sufficiently well defined to be presentable as a mathematical theory, after due allowance for the fact that in cybernetics one tends to employ practical simulation before a rigorous theory is developed. Second, we confined ourselves to digital methods of representation of information and to digital information processors. This selective approach resulted in a book consisting of the following basic parts: the theory of algorithms, including programming of general purpose digital computers and universal algorithmic programming language; the theory of digital automata, including Boolean functions and the design of general purpose digital computers; the theory of digital self-organizing systems, including the elements of decision theory; and finally, mathematical logic, propositional calculus, restricted predicate calculus, and formal arithmetic. Mathematical logic is considered here as the basis for automation of the process of constructing deductive theories starting from a given set of axioms. The detail of our presentation varies with the novelty of the subject. The more recent areas of cybernetics itself are discussed in great detail, and the theorems are supplemented with rather thorough proofs. However, such topics as the abstract theory of algorithms and mathematical logic, which properly belong to traditional mathematics, are stated more briefly, and the proofs are usually omitted. There are, nevertheless, departures from this rule. These occur whenever the author felt the need for a comprehensive treatment as when dealing with such fundamental postulates of mathematical logic as Gödel's theorem on the incompleteness of arithmetic or the theorems showing the algorithmic unsolvability of certain problems. The present book is no substitute for specialized monographs dealing in depth with. We had a glitch here. All right, we're back. The present book is no substitute for specialized monographs dealing in depth with the individual topics covered here. However, such specialized texts are inaccessible to well-prepared readers, and it has been the author's experience that their mere availability does not by itself guarantee the dissemination of the information to the non-specialists. One example of this is the fact that the above-mentioned Gödel's theorem, which is of fundamental importance for all of mathematics, is still only hearsay to most mathematicians. We attempted here to reach a wide audience of mathematicians and engineers and to help them in acquiring the minimum of knowledge which is necessary for comprehension of the theoretical problems in modern digital cybernetics. We assume, and then only in chapter 4, that the reader will be familiar with those elements of mathematical analysis and probability theory which are known to virtually every engineer, let alone mathematicians. The less widely known mathematical theories required for us the less widely known mathematical theories required for an understanding of the book have been incorporated in the text. For example, the set of postulates of probability theory in chapter 4, section 2. For those readers who want to deepen their knowledge of the individual topics or wish to see detailed proofs of theorems which have been given without such proofs in the book, we shall now survey some books and specialized monographs relevant to the topics covered in various chapters. Unfortunately, not all material is covered by such monographs. The first part of the book describes the basic theoretical universal algorithmic systems, normal algorithms of Markov, the algorithmic system of Kolmogorov, Uspensky, recursive functions, post algorithms, and Turing machines. The proofs of the algorithmic unsolvability of some simple problems are also given. There is at present no book summarizing all aspects of the theory of algorithms. Not even all the above mentioned problems are treated exhaustively in the monographic literature. Among the principal works on individual algorithmic systems, let us mention the following. On the Theory of Normal Algorithms, by A.M. Markov. On the Theory of Recursive Functions and Turing Machines, Introduction to Mathematics by S.C. Klein. And Lectures on Computable Functions by V.A. Uspensky. The second chapter deals with the theory of Boolean functions and its applications to the theory of discrete automata. These problems are discussed in greater detail by V.M. Glushkov in the Synthesis of Digital Automata. In addition, the second chapter discusses the fundamentals of propositional calculus, a subject which is well covered by P.S. Nokarov in Elements of Mathematical Logic. The third chapter is devoted to the abstract and structural theory of discrete finite automata. A more detailed treatment of these problems can be found in the above-mentioned book by Glushkov. These problems are examined from a somewhat different viewpoint by N.E. Kabrinsky and R.A. Trackton brought in the introduction to the theory of finite autonoma. The fourth chapter covers the basic theory of discrete self-organizing systems. A quantitative measure of self-organization and learning is defined. The behavior of stochastic autonoma and of autonoma operating under conditions of random external influences are investigated. Special attention is paid to the problem of pattern recognition and to the theory of a special class of devices, the so-called alpha, for the solution of this problem. Some problems are in stimulating conditional reflexes and learning processes involved in concept recognition and concept formation are examined in connection with the concepts of self-adaptation and optimizing control. We describe a number of general methods of solving extreme problems, the method of steepest descent and its refinements, the simplex method of solving problems with linear programming, and the method of sequential analysis for the solution of problems in dynamic programming. At the present time, there is no single book summarizing the contents of Chapter 4. Sorry, we had a satellite glitch. At the present time, there is no single book summarizing the contents of Chapter 4. Moreover, almost all the problems analyzed there, except for the method of steepest descent and the simplex method, have not as yet been discussed in the monographic literature. A number of problems similar to those examined in this chapter, but not quite identical to these, are discussed by F. Rosenblatt in Principles of Neurodynamics. Even though there are many monographs on the principles of solving extraneous problems other than the method of sequential analysis, we shall not list them here since these problems have no direct relationship to the basic subject of this book. The fifth chapter deals with the design of general-purpose digital computers and their programming, a subject treated in so many different books that it would be difficult to list them all. As far as programming is concerned, we can mention, for example, the monograph of B.V. Nedenko, V.S. Korolyuk, and E.L. Yashenko, Elements of Programming. On the other hand, as far as computer design is concerned, there is no detailed exposition of the material on the level we require, in spite of the existence of many good special monographs on this problem. In these, the principles of computer design are usually discussed from the general theory of algorithms. The fifth chapter also gives a detailed description of the universal algorithmic language ALGOL 60, as well as some examples of programming in ALGOL. These examples deal with the various problems, primarily those concerning self-organizing systems. In particular, we discuss the problem of programming the perceptron and a simplified model for the processes of biological evolution. Again, the situation in the monographic literature is not encouraging. The report on the algorithmic language ALGO 60, P. Noer, editor, Communication, ACM 1960 299 to 314, is a brief treatment of the ALGO concept, but is not useful for a practical study of ALGO. The last sixth chapter gives a synoptic exposition of the foundations of the restricted predicate calculus, including the formal system of Genzen, the formal arithmetic, including Gödel's theorem on the incompleteness of arithmetic. Detailed proofs can be found in the above-mentioned books by Klein and Novikov. This chapter also deals with automatic formulating, and the proof of theorems in deductive theories. These problems have not been treated as yet in the monographic literature. Our list of subjects shows that the book omits many interesting topics of modern cybernetics. The previously cited selection criteria would permit the inclusion of a discussion on linguistics or on the elements of the theory of games. However, the already quite considerable size of the book forced the author to give up any idea, including other material. But as it is, the book covers those problems which can be regarded as the basis of the present discrete theoretical cybernetics. The author therefore hopes that the book may be of help in acquainting its readers with the mathematics of cybernetics. The book should be especially useful to persons working on various applied aspects of cybernetics and wishing to understand the theory. The author has utilized the material from his lectures in various aspects of cybernetics and the mathematical logic given in various reports of cybernetics and mathematical logic given in 1959 and 1962 at the at the University of Kiev and the Kiev Institute for Dissemination of Scientific and Engineering Knowledge. Some of this material, for example, the theory of algorithms, has been published previously in the form of technical reports. This book can be regarded as the first reasonably complete Russian textbook for students of the above-mentioned field of cybernetics. So this is a translation, obviously, but it's hard to find a good translation of certain things. I'm delighted to find this. So we're going to go through the table of contents, and then we're going to cut this off. This is just a preface and the table of contents, and then tomorrow we'll go through chapter 1, if everything works out. So we did the preface. Chapter 1 is the abstract theory of algorithms. Alphabetic operators and algorithms. Normal algorithms. The Kolmogorov-Obshinsky algorithmic scheme. Other theoretical algorithmic systems. The concept of algorithmic unsolvability. Okay, chapter 2. Boolean functions and the propositional calculus. So you got Boolean functions, Boolean algebra, complete sets of Boolean operations, application of Boolean algebra and the theory of combinational networks, and then propositional calculus. So chapter 3, the theory of autonoma, abstract autonoma, events and representation of events in autonoma, the analysis of finite autonoma, the abstract synthesis of finite automata, minimization of abstract autonoma, the structural synthesis of finite autonoma. Okay, now you have chapter 4, self-organizing systems, concepts of self-modification and self-organization in autonoma, some auxiliary concepts from probability theory, a quantitative measure of self-organization and self-improvement in autonoma, autonoma with random transitions, the problem of learning in the pattern recognition, theory of learning in discrete alpha perceptrons, operation of discrete alpha perceptrons in the self-education regime, logical classification systems and conditional probability, self-organization. I got mixed up here. Okay, we'll go back. So, operation of discrete alpha perceptrons in self-education regime, logical classification systems and conditional probability machines, self-organization and self-adjustment, methods of solving complex variational problems. Let's see. Electronic digital computers and programming, the general purpose programmed automation, the structure of modern general purpose programmed autonoma, concepts in programming, the universal algorithmic language ALGO 60, Examples of Algo 60 programming. Okay, and then the predicate calculus and the automate automation of the processes of scientific discovery. Basic concepts of the predicate calculus. Formal arithmetic and Gödel's theorem. Automatic construction of proofs and deductive theories. And there's references in the index. So yeah, wow. So I'll start chapter 1 tomorrow, and yeah, I think that'll be it for now. Yeah, this is some heavy duty stuff, but it's my first time looking at it, and I need to familiarize myself, and thought I'd take you along. So thanks for joining me, and sorry for the rough connection. We'll see if we can do anything about it. Okay, thanks again. This is Military Industrial Museum. Make sure you subscribe and like, and check out my little YouTube shorts. I'm using AI to make some pretty good rap songs. So a lot of them are on technical subjects. Okay, we are outie.